All right, we're doing Euclidean geometry today, guys. Who remembers, who can tell me, what does the symbol here in the middle mean? What does the symbol over here mean? Anyone? Queen Jasmine.
Congruency?
Yes, absolutely. You don't sound sure, but you are correct. 100%. It's congruent. Beautiful stuff. Amazing. So we must remember, what must we remember about congruent shapes? What do we know about congruent shapes?
Congruent shapes are exactly the same.
Like just, you deserve all the flowers. That's it. That's exactly it. They are exactly identical. They are 100% identical. Okay.
My name is Flower.
You know what I mean? Jasmine is flower. That's why we give you all the flowers. You know what I mean? I love to see it. Love to hear. You know, you must live up to your name. I love to hear it. Well done, Jasmine. You're amazing. Very nicely done. Very nicely done. Yes. All right, guys. So remember, not only do the angles need to be the same, the sides need to be the same. Everything about them needs to be the same. Hi, Snotile. Excellent. All right. So we know in this particular two triangles over here, we need to prove that triangle DEF is equal to GHK. So when we are mapping out our two triangles, Jasmine, I'm going to unmute you in just a second. I just need to get this out. All right. When we are mapping our two triangles, we are proving. So we're always going to start by saying proof. And then we're going to say in triangle DEF. Now, remember, guys, if they don't give you the triangles that you're trying to prove, we have to go DEF, and then we need to make sure that we're moving in the same direction. Now, you'll see that I started somewhere, and I went towards 75. And that means that in this other triangle, I have to start somewhere and move towards 75. And then the side that comes after 75 needs to be on my right-hand side because I'm going towards 75 and then the other side is on the right-hand side of 75. So I need to start here, move towards 75 and then the other side on the side. So if I want to then name this triangle, I have to say, and triangle GHK. And I know that many of you are probably saying here, well, duh, Teacher Coco, they told us up there. Over here, they told us to say GHK. You're not really telling us anything new. Okay, there is going to come a time where they're not going to give you the triangles. Okay, yes, Lesedi, we're doing revision. All right, there's going to come a time where they're not going to give you the triangles and you need to figure them out on your own. So we need to understand how they get them. Okay. Thank you, Teacher Nels. I actually forgot about the recap. Okay. Yes. Thank you. I'm just going to write that on the side. Okay. I'm going to write here. The reasons are side, 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 angle, side, angle, side, angle, angle, side, angle, and right angle, hypotenuse, side. Remember, guys, side, side, angle, no such thing. No such thing. All right. Yes, Jasmine, I'm happy to take your question. Or your answer.
Did I have a question or?
I'm seeing you in the chat saying, hi, still here. So
no, I changed from my phone to my computer. So.
Oh, okay. Excellent. Okay. Did you disappear for a second? Okay.
Yeah.
I see. All right. Well, welcome back in either case. You didn't miss much. You didn't miss anything much. Okay. All right. Cool, guys. So let's have a look at this triangle over here. Let's talk about what's happening in triangle GHK for a second. Okay. Before we continue with everything else. In triangle GHK, before we start the proof of congruence, what do we notice? What does this tell me, guys? What do these two things tell me?
Equal.
Good. I heard somebody say that they're equal. Excellent. That means that GH is equal to GK. What kind of triangle, Anna? You completely gave it away. Yes, good. That tells me that this is an isosceles triangle. Good. This is an isosceles triangle. And we know that the base triangle, the base angles of an isosceles triangle are going to be equal. Therefore, if H is equal to 75, K is also equal to, what is K equal to? Not 30, Ayabonga, they are the same. Good, guys, that's it. K is equal to 75 degrees. Now, our reason in this case, we cannot just say isos. We can't say isos triangle. Okay, they do not accept isosceles triangle anymore. All right, we have to say, for a reason, we have to say opposite angles of equal sides. Okay, we must write this. We must write that. Okay, alternatively to that, if they hadn't given us that these two sides are equal, but they had told us that this is 75 and this is 75, then we could then say that GH is equal to GK. And our reason here would be opposite sides equal angles. Okay, so we can use both of these alternatively to prove one or the other. I hope that makes sense. Okay, it's just something that we can do in terms of the way that they've structured our triangle for us. All right, good. Now we know that angle K is equal to 75. What does that, no, Anna, unfortunately not. For an isosceles, if we're proving that one at the bottom, we have to use opposite angle equal sides. Okay. Now, Anna, we can then say that angle G is equal to how much? Now you can use the idea that they are angles in a triangle. How much is angle G equal to, guys? That's it, Siyabonga. Good, 30 degrees. And our reason now for the top, yes, you can. If you're talking about G, yes, you can, but only after you've told them what K is. So you can't say G without proving K first. That's why we're doing it in this order. All right. And for G being 30, we can say angles sum in triangle, or the sum of interior angles of a triangle, whatever it is that you name it, it must just be one of the reasons for angle sum in triangle. Now then, guys, we can say in triangle DEF and triangle GHK. Right. Now let's look at our two triangles, guys. What have they given us? What information have they given us? Yes, Jasmine.
They have given us on triangle GHK that the two sides are equal and it's an isosceles.
Good. So now we want to compare this triangle with that triangle. What do we notice is the same? What is congruent in each of these triangles?
What is congruent in both the triangles is the angle.
I'll give you a hint. We know that DF, so DF, side DF must equal to which side?
Angle.
Have a look at how I've mapped it. DF is equal to, so
GK needs to be equal to DF.
To DF, good. So DF is equal to GK. Excellent. And what is my reason, Jasmine? Don't run away. What is my reason?
Oh, I did not run away. Reason.
Okay, think about this. What do these things mean?
Equal. Angles are equal.
Good. So what is our reason for saying that the sides are equal? If you're stuck, Diabona's giving you the answer. Have a look in the chat.
Oh, yeah, it's given.
It's given to us. Good. They've given that information to us. Good. It's
Thank
given.
you, Am I saying the name right?
Liabona.
Liabona. Thank you.
Excellent. Awesome. All right. What else do we know, guys? What else do we know? Okay. I'll give you guys another hint. That angle. Angle E
is equal to angle H.
Beautiful. Middle angle is equal to middle angle. What is our reason here?
Also given.
That's it. Given. Good. One more. We've got two reasons and we've got an angle and an angle. Oh, no, I'm lying. We have a side and an angle. Side and an angle. Let's think of the last one. Let's look. I need to put in the information we've actually come up with here. Right. This is 75 degrees and this is 30 degrees. What else do we notice?
Angle D and E is also equal. And
good.
Also given.
Okay, in this case, we can't say given because we solved for G, right? We figured out that G was 30 degrees. So instead of saying given, we're going to say proved above. Okay. Because we proved it above. And is it a side or an angle, Jasmine?
It is a side. Angle.
Good.
Side.
Good. No problem. Now we can say, therefore, I'm just going to write it up here because I've run out of space. Therefore, triangle, finish up for me.
Triangle DEF is congruent to GHK.
GHK. And what is our reason?
Side angle.
Beautifully done. Side angle. We could also say angle side. It will be the same thing. But Jasmine, every time, amazing work. Very nicely done. Awesome. And thanks so much, guys. Do you know what? I want you guys to almost be like the Avengers. You know how the Avengers have each other's back? Ne? Ah, yes, SAA, yes. That's it, Apiwe. So I want you guys to be like the Avengers. When you see somebody answering a question and they're kind of stuck, I want you guys in the chat to kind of help them out. Ne? Don't just leave them standing there being like, no. Okay, you guys need to be in the chat there on some, I got you. The Hulk is behind you. Captain America's got your back. You guys must like cover for each other. Okay, we're a family, guys. We're a family. So you guys need to like cover up for each other there so that when somebody's stuck, they need to know that they're not alone because the Watobians, their Watobi families got their back. Give me a thumbs up if you guys get that. That's it. See, that's it, Sishe. Okay, that's it. We're going to assemble. The Avengers are going to assemble. See, love to see it, Sibusi. So excellent. I'm glad you guys are here for each other. All right. Amazing. Good, Funzo. Good, Apiwen. That's it, Ayabonga. I need you guys to be here for each other. All right. That's it, Anna. We're fighting this together. We're fighting the maths together. Okay. Nicely done. That's it, Mirula. Even with all your awkwardness and cringe, you're there. I know you've got our back. You've got our back. All right, guys. Let's look at this next one over here. I'm going to make it a little bit bigger. All right. And then I'm going to move this duty down because we're going to talk about him in just a second. All right. Now, let's look at what we've been given over here, guys. It says here, we've been given two triangles, triangle ABC and triangle CED. Right. I want you guys to read the rest of the information they've given us. And I want you guys to tell me, what information have we been given? Any ideas, guys? It's literally just a matter of reading. Anybody?
AC equals to DE.
Beautiful. AC, who said that? Who said that?
Samsung.
Ah, Samsung, nicely done. AC is equal to DE. Beautiful. Thank you, Samsung. Thank you, Samsung Galaxy. What else do we need to know? Good, that angle D is equal to 30 degrees. Thank you, Nomaklubi. Good, angle D is equal to 30 degrees. Good, angle C is common, Ayabonga. They haven't told us that. Okay, so we need to be thinking of the information that they've given us up top. Okay. All right, angle A, the Abona, they have not given us that information. They haven't told us that angle A is equal to angle D. Good, no Mahubi, that's it. Angle E is equal to X. Good, that's the information they've given us. Ah, Zama, I like that one. They've told us that AB is parallel to CD. And as soon as we see parallel lines, guys, what do we need to think of? As soon as we see parallel lines, we need to think of? Who remembers? What kind of angles come into parallel lines? Anybody remember? Ah, Tyrika. Yes, that's it. The fun angles. Up here where you're not wrong. Absolutely. The fun angles, or the co-interior, the corresponding, and the alternate angles. Those are definitely going to play a role. So them telling us that two lines are parallel, they're not just telling us that for fun, guys. It's because we're going to have to use alternate or corresponding or co-interior angles somewhere. Somebody, guys, we're all missing one more important piece of information.
Angle GCE is equal to 2x and angle ACD is equal to x.
Beautifully done. Excellent. Angle ACD is equal to x and angle DCE is equal to 2x. Beautiful. Last bit of information would be this one over here that everybody's just decided, nah, man, we ain't going to look at it. That one, BC is equal to CD. Okay, that one is also correct. Sibusiso, I swear I could just like, you deserve a high five and like, you are the man and a big ups for exactly what you've said, because what you've told me is basically the crux of what we need to do today. Simply, like you're just beautiful. We need to remember, guys, that angle C is on a straight line. Okay, and that tells us a lot. That tells us so much. Okay, guys, you guys are just amazing. Like, well done to everybody. Nicely done. Good. All this information that you guys have given me is very important because it's going to make up part of the question that we need to answer. All right, let's start with 4.2.1. It says here, determine the value of x. Who's got an idea? How do we determine the value of x, guys? Who's got an idea? Not quite inverse proportion, because in this case, Anna, we don't have any proportions. Remonedwe, you are almost there. You are like so close. You are like right there. Okay. Good. Say equal 180. Good. Not so much angles on a straight line. Good. Up here, you're a whole rock star. Some angle, some in triangle. And Funzo, we cannot say that x is equal to 30. It's not. Because if you map out your fun angle, it's not going to be there. Anna, yay! That's it. Good. We can say 2x plus x plus 30 degrees is equal to 180 degrees. Anna, you're a whole rock star. Like, I just mean, whew, like, thank you. And your reason is 100% accurate. The reason for that is angle, sum, and triangle. Guys, you guys are going to make me cry. You guys are just like, you guys are amazing. Like, just Just cheers all around. Apiwe. What's up, my
Hi,
sweetie?
ma'am.
Hi, my sweetie. What's up?
Ma'am, I just wanted to ask if we say x is equal to 30 plus x, which is angle E, and we say exterior angles is equal to 2 interior angles of a triangle.
Absolutely, you could, right? Now, the problem there is that the answer you're going to get isn't correct because the exterior angle is that one. And we don't know what that is.
Oh, thank you, ma'am.
Okay. But X does make up that exterior angle. Does that make sense? It makes up part of the exterior angle, not the whole of it. All right. I think Anna has done the job for us. Everybody lead us to the answer, guys. Lead us to the finish line. Get us to the finish line. What is X equal to? What is X equal to? Ah, nicely done, Tyrika. Mirula, I want the answer for X, not just the interior angles, just the answer for X. Beautifully done. Good. 2x plus x will give us 3x. And then I'm going to take the 30 over to the other side and it's going to become minus 30. So I'm going to end up with 180 minus 30. So 3x is equal to 150. And then I'm going to divide both sides by 3. Divide by 3. Divide by 3. Therefore, x is equal to 50 degrees. Beautifully done. So now what this tells us is this angle E over here is 50 degrees. And this angle over here is also 50 degrees. What about angle C over here, guys? How much is this angle over here equal to? Nicely put, Remonelwe. Excellent work. This is equal to 100 degrees. Wonderful. Now, there are two things we can then do from here, but we're going to do them as we answer this question. Right. Question 4.2.2 says here, prove that triangle ABC is congruent to triangle ECD. So before we even get there, let's put some things together here, guys. All right. So in this triangle over here, somewhere I'm going to need an angle, guys, because I've got a side and a side. I've got a side and a side. I do not have my third side. So I'm going to need an angle in this triangle. Where can we find that angle in this triangle? I'm going to tell you guys now. I'm going to tell you guys now that Sige has done the Lord's work. And he's already told us that C lies on a particular type of line. He's told us that C lies on a particular type of line. That's it. Yo, Ramonelwe, my word. Right. Good. Ah, amazing. Good. They are supplementary. Good. Jasmine, how do we put this together? What are we going to say about this angle C? Let's put it together.
Okay, but like I skipped a part because
That's okay.
where 50 is will be 30 degrees, right?
Good. Here, no, over here.
No.
You mean over here?
Yeah.
Absolutely. And that's the angle C we're looking for. So just for the sake of naming it correctly, this is how we're going to name it, Jasmine. You're going to go angle BCA, right? We're going to say angle BCA is equal to, how much is the angle C equal to? You've just given me the answer.
No, wait. 30?
Good, it's 30 degrees. It's 30 degrees. Excellent. What is our reason?
Our reason is angles on a straight line.
Absolutely. I don't like how you're phrasing all your answers as questions when you've actually said the correct things. Good. It's angles on a straight line. Okay. Beautifully done. That's exactly what I was looking for. Well done, Jasmine. That's it. Okay. Well done. Excellent work, my sweetie. Thank you so much. Okay, good. So now we know that angle BCA is equal to 30 degrees. Okay, good. Teacher Nels, I see Anna saying supplementary angles. She is allowed to say that. She just needs to say adjacent. Anna, you just need to add the adjacent supplementary angles. Okay. Okay, sorry, adjacent angles are supplementary. You can say that as well. Adjacent angles are sub. You're allowed to do that on that particular line. Okay, iPhone 11, first of all, tell us your name. Okay, all right. But I'm going to explain to you why it's equal to 30, because this is a straight line, right? And over here on my straight line, this part is already equal to 100. That part is already equal to 50. And we know that angles on a straight line would equal 180. So I would then get that C, this angle C, plus 50 degrees plus 100 degrees is equal to 180 degrees. Okay, and then everything else would go over to that side and we would minus 180 minus 100 minus 50. Therefore, C would be equal to 30 degrees. Okay, I hope that makes sense. Just give us a yes, ma'am, in the chat if you understand where we all got the C is equal to 30 degrees from. All right. Hi, Sanele. Yes, excellent. All right. Teacher Nels is going to change your name, so we don't have to call you iPhone 11. We'll call you Sanele. All right. Now that we've got this very important bit of information that we need over here, I saw somebody say, ma'am, can I not say that angle A is equal to 50 degrees? You absolutely can because of alternate angles. You can do that. But I'm going to show you something very quickly. I just want us to get through the answer. All right. So we're going to say in triangle ABC and triangle ECD. I need 3 reasons, guys, to prove congruency. Please give me those 3 reasons. Good. Angle A is equal to angle E. Good. All right. We can say that angle A is equal to angle E. Excellent. Good. What is our reason here? Our reason is we had to solve for both of those. So we're going to say proved. Okay. They've been proved. We've proved for both of those. Good. And then Sandakache says AC is equal to DE. Beautiful. Sandakache, what's our reason there? Why is AC equal to DE? What's our reason? Good, beautifully done. It's given. Excellent. It's given. Good. Liabona then says angle C is equal to angle D. What is our reason, Liabona? Remember, guys, this is an angle. This is a side. What is our reason over here, Liabona? For angle C being equal to angle D? Anybody got any idea? It's not corresponding angles, I'll tell you that. And remember, Sibusiso, corresponding angles need an F. So I don't see where the F is over here. No, we don't have it. It's not common. Good. Yes, it's proved. It's proven. Good, Liabona. It's proved. Okay, good. And that is an angle. Good. Now I've got my 3 reasons. So I can then say, therefore, triangle ABC is congruent to triangle ECD. What is my reason? Give me a reason, guys. Oh, not side angle, Sandakahle. Look at it properly. We've got a side and an angle. Oh, I'm lying. We've got an angle and a side in between. Okay. F and F. B is equal to 100 corresponding angles. Yes, teacher Nels, you're 100% correct, my sweetie. Now I'm teaching you. You're correct, but the two angles that they had mentioned were not corresponding. That's why I said no corresponding. They are corresponding, yes, but not the two angles that they've mentioned. B and C are not corresponding. Okay, that's why I said no. All right, Hannah, be very careful, my sweetie. Look, if we say angle, angle, side, then, oh, actually you can, yes. But Hannah, that's not the reason that you've used. Okay. Up here, C is not common. Okay, C is split up into different pieces. So we can't say that C is common. Okay, in this case, we would say angle, side, angle. All right, that's what we would say here. Okay, it's not common. It's only common if it's the same angle in both triangles. And unfortunately, it's not. Okay, and it's also not as the same, yeah, it's not the same angle in both triangles. All right, so Hannah, remember, if we use angle, angle, side, then somewhere in our proof, we should have used that BC is equal to DC. Only then can you say angle, angle, side. All right, but the way that we've proven it, we need to use angle, side, angle. All right, so it depends on how you've proved it. All right, give me a number out of 10. How comfortable are we with congruent triangles? With congruence just in general. Samuel's like, more than. I love it. Ooh, Remo, that's a lot. Motra, I wonder how we need to get that 9 of yours to a 10. You need to let me know. All right. Nice one, Imelda. Okay, maybe just a bit more practice. I think it takes a little bit of getting used to in order to get there. All right. Api was like infinity. Nicely done, guys. Okay, we just need to remember, guys, everything that we've been given is already there. We just need to put it together. All right, now let's talk about quadrilaterals, guys. Let's talk about quadrilaterals. Now, I know that we've spoken in depth about the properties of quadrilaterals. So I'm going to give everybody 5 seconds to take a screenshot of this area over here where we have the square and the rhombus. And I'm going to add in here, guys, that the square is a parallelogram. And I'm also going to add that the rhombus is also a parallelogram. Okay. Take a screenshot. You've got 5 seconds, everyone. 5, 4, 3, 2. I'm definitely not counting right. My fingers are not doing the right things. 2, 1, and 0. All right. Next one. Let's go. All right. Then we have the kite and the rectangle. Now, the kite is definitely not a parallelogram. It's not, unless it's a diamond. But a diamond is also a rhombus. So no, it doesn't count. So the kite, not a parallelogram, but a rectangle is a parallelogram. Okay. So take your screenshots, guys, 5 seconds. All right, that's it. Last 2, your parallelogram, your actual parallelogram. And now I feel like, because I was already doing it, I have to do it. A parallelogram is a parallelogram. Is a parallelogram. But a trapezium is not a parallelogram. Okay, so 5 seconds, guys. Take your screenshots. Level up, level up, level up, level up, level up. I'm going to sing that song for the rest of the night. Thank you, teacher Nels. 5, 4, 3, 2, 1. Let's go. Level up, level up, level up, level up, level up. That time I can't even dance to save my life. But yeah, it's now stuck in my head forever. Thanks, teacher Nels. You're wonderful. Okay. All right. Okay, guys. Now let's talk about the actual maths. Okay, let's level up and talk about the maths. All right, now, I'm going to look at this example that they've given us over here, guys, and I'm going to say here that this example says here that prove that ABCD is a parallelogram. So my question is, can we use the properties of a parallelogram to prove that a parallelogram is a parallelogram? Yes. Can we? Okay, let me ask this in a different way. Let me ask it differently. Can I use the word car in the definition of a car? No, absolutely not. I can't, because Jasmine is laughing at me. Yes, I see the laughter. I can't use the word car if I'm trying to find the definition of the word car. So if they say to me, prove that ABCD is a parallelogram, can I use the properties of a parallelogram? No, I cannot. I can't do that at all. Okay, I have to use what they've given me to prove that it's a parallelogram. I can't say now opposite sides are equal properties of a parallelogram. How? I'm proving a parallelogram. How can I already say that the properties of a parallelogram apply? They don't, because I'm still trying to prove it. All right, but one thing I do know for sure is that my parallelogram is made up of what? What is it made up of? Think of the two shapes that make up my parallelogram. What is my parallelogram made up of? Yes, Jasmine.
Two scalene triangles, because
Good.
the diagonal line is dissecting it into two.
Beautiful. There's scaling, but more specifically, what are we going to have to prove about these two triangles? That they're what? And I'm going to tell you, the first half of the lesson was your clue. What are we going to have to prove about these two triangles? That they are?
That the two triangles are congruent, right?
Yes, that's it. Excellent. That's it. We're going to prove that these two triangles are.
I found one reason though.
Yes. Oh, absolutely. Wait. We need to map them out properly. Okay, wait. We can't just start with the reasons. We need to start by saying, in triangle. In triangle. All right, let's find them in order. Let's find them in order. Where do we start? Let's think about this. In triangle, all right. If I say triangle A, B, C, what would my next triangle be? I'm going to say A, B, E, and triangle. Now I have to map out the other triangle, but I need you to see this one has a line and this one also has a line. And I went from A right over the line onto the other one. So in the other triangle, I have to go right over the line as well. Okay, so guys, for those of you saying ADC, if I do this, if I go ADC, I'm not going to go over the line. So where do I need to start in order to go over the line?
You to start at A.
Listen to Remo. Remo's got the right idea. Zama also has the right idea. Very, very well done. Think about it. I need to go over that line over there that I went through. So if I start at C, where am I going to go from here, Jasmine? I have to go over the line. So I'd go from C to, I have to go this way over the line.
From C to D and then A.
Good. So my next triangle will be triangle. Give me the triangle.
triangle CDA.
Beautifully done. That's it. And you can thank all your Avengers in the chat because they did the most. They did. Thank you so much. You guys are beautiful
Well
stuff.
done. Well done.
Thank you. Thank you. Thank you, everybody. You guys are amazing. Good. So remember, guys, we need to learn. Remember in the other questions, they gave us the triangles. In the parallelogram, they don't give you the triangles. So you need to learn how to map them out in the correct order. All right, good. So we went A, B, C, and C, D, A. Now we can start with the reasons. Let's start with the reasons. Now remember, guys, these arrows tell us that AD, and I saw you say this, Anna, I did, but AD is parallel to BC. Be careful, Anna. Did they say that AB and DC are parallel? Have they said that? Did they put the arrows there? Did they put the arrows on A and D? I mean, A, B, and C, D. Are there any arrows? Good. That's it, Liabona. They are not parallel, Anna. They are equal. Good. So we need to be very careful. Be very, very careful. All right. Make sure that you're seeing the difference. You're 100% correct. AD is parallel to BC, but AB is not parallel to DC. It is equal to DC. Now, guys, we're proving congruency. Give me reasons, please. Anybody got any ideas? Let's go. Good. Nzalo, beautiful. AC is common. Good. AC is common. Excellent. Common. Good. Sandagahle. AB is equal to DC. Beautiful. What's our reason? Sandagahle, you must always give me reasons. Is equal to DC. Good. And our reason is given. Excellent. Good. And then remember, guys, we need to use the correct fun angles. Because things are parallel, we need to use the correct fun angles. Right. So Liabona is saying angle A is equal to angle C. And that is you using the properties of a parallelogram to prove that a parallelogram is a parallelogram. We can't do it. We can't do it. We now need to look for a fun angle, guys. Find me a fun angle. Look for either an F or a U or an N or a Z. Look for one. Okay, now Rabetsu says C2 is equal to A1. Now, if I had to do that, I'd have to use alternate angles. But Rabetsu, have a look. These are the two lines that I would have to use. I would have to use AB and CD. Is AB and CD, are they alternate? Are they actually parallel lines? No, they're not. No, they're not. So we can't say that. We can't say that. We have to use the other parallel lines. Not co-interior remo, have a look. We're going to use it this way instead. We're going to go past our two parallel lines in this direction instead. So which two angles are then equal to each other? I think Sandagahle has the correct angles that we're looking for. A2 is equal to C1. Good. A2 is equal to C1. And our reason here would be alternate angles, right? Angle A2 is equal to angle C1, and that is alternate angles. And don't forget to write your parallel lines. AD is parallel to BC. Good. Now I've got a side, and an angle. Remember, guys, side angle is not a reason. What is our actual reason going to be here, guys? Therefore, that's it, Anna. Beautiful. Triangle ABC SARS is congruent to triangle CDA. Good. And our reason would be side angle, side. All right. Samuel's like, ma'am, you're watching. What are you watching? You're supposed to be doing maths. You're supposed to be doing maths. All right. Now that we have proven that each of the sides is equal. Can we use co-interior? Yes, we can. But remember up here, in order for us to use co-interior angles, these two angles need to equal 180. Remember, co-interior means that together they equal 180. And at the moment, we don't have any measurements for anything. Okay, so, okay, all that's going to do is prove that my quadrilateral is, the interior angles of my quadrilateral are equal to 360, and that's not going to help us because every quadrilateral is equal to 360 on the inside. Okay, so that's not going to help us. Sihle says, what's the difference between side angle and side angle side? All right. Okay, so here's the problem with using side angle, right? If I have side angle side, let me draw two triangles. Okay. If I have a side, and an angle in between, this is side angle side because my angle is in between. Now, if I had to use side angle, here's the problem with this. I could do this. I could go side angle, and this angle would be equal. And then in my second triangle, I could do this, right? And then my angle could be equal. This side and this side could be equal. These two things are not the same thing. So side angle cannot be a reason because the way that I can structure my third side will not make them equal to each other. Okay. Inside angle side, the angle is included. Inside side angle, the angle is sitting on the end. Therefore, our third side can be whatever length it wants. And that's not going to help us prove congruence. All right. So we cannot use side angle is never ever a reason. Okay. We can never ever use side angle. All right. Okay. Awesome, Sihle. Good question, by the way. Good question. All right. Excellent. Now that we know all of this, guys, we know then that we've got a diagonal, we've got opposite sides that are equal, right? And we've got opposite sides that are parallel. Therefore, we can now say, therefore, ABCD is a parallelogram. Okay, and our reason here is going to be that our opposite sides are equal and our opposite angles are parallel. And those two things, not opposite angles, opposite sides, sorry, opposite sides are parallel. And those two things are properties of a parallelogram. Okay, but in order for us to prove that, we need to prove congruency, because once we've proven congruency, that automatically tells us that AD is equal to BC. And that also tells us that AB is parallel to DC. Oh, well, not parallel, sorry, the angles are equal to each other. Angle D will equal to angle B. And the whole of this angle will then be equal to that angle. And that's why we need to prove congruency. Who remembers what we call it after we've proven congruency, and we can then say that all the other sides are then the same? It was this long thing that I made you guys learn. It sounded like the name of an organization. Does anybody remember? Bonus points for whoever remembers. It took you like 3 seconds to remember. Yes, Mirula, you guys are amazing. That's it. It's called CPCTC. And for those of you who are seeing this for the first time and you're like, huh? What the hell? What is that? It's fine, guys. CPCTC basically means that congruent properties of congruent of congruent triangles are congruent. Okay, so if we prove that something is congruent, if we prove that two triangles are congruent, then automatically all the other sides then become equal to each other. That means we know that AB is equal to CD. That also means that BC will be equal to AD, because we've proven congruency and we know that congruent triangles are the same everywhere. That means that all the other things about our triangle will be true. The angles on each side will be equal to each other. All of those things are then correct. Okay, give me a thumbs up if the CPCTC makes sense. Okay, if we can prove congruency, it means everything else about the two triangles automatically becomes true. Okay, even if we use angle, side, all the other sides then become equal to each other. All the other angles then become equal to each other. And that's what CPCTC means.